Hello AP Physics 1, it's Mr. Ng with another tutorial on a homework problem. This is number 17 from chapter 7. It's a momentum problem. But really, it's a review of motion in two dimensions. Let's go through it. So a tennis ball has a mass of 0.60 kilograms and a speed of 25 meters per second, and it hits the wall at 45 degrees and it bounces off at 45 degrees. So the problem wants us to calculate the impulse, which is the change in momentum, meaning the magnitude and the direction of that change in momentum. Okay, so here's a diagram from the book. Let's break it down a little. If you look at these two motions, you can reduce them down to x's and y's, right? X's and y's. And if you notice, the two y's are the same. So there's no real change in y. Instead, really, the change is with these two x's, right? There's an x going in this direction, and it bounces off, and then x goes in the other direction. So really, in this problem, we just have to work off the x-axis, which makes things a lot easier for us. And more so, if you look at the actual angle, this is 45 degrees. This vector is basically our velocity, 25 meters per second. So here, this is our opposite, this is our hypotenuse. So here, to find our x, right, we could just use sine, namely 25 sine 45 degrees. That is the magnitude of our velocity along the x. So if you do that math, if you punch it in, you're going to find that these magnitudes are 17.7 meters per second. Let's call this one positive, and this one is going to be negative 17.7 meters per second. So now we're really close to being finished. Let's go back to our equation for impulse. J is basically the mass times the final minus the initial, right? So our J is going to be our mass, which was 0.60 kilograms. Our V final was negative 17.7 meters per second, minus our V initial, which is 17.7 meters per second. You do a little bit of math here, and it becomes J is equal to negative 2.12 kilogram meters per second, or it's 2.12 kilogram meters to the left. That's what this little negative sign means. It's going that way. A magnitude and direction. There you go. It's pretty darn easy. Thank you very much for watching. And all I did was I did a little bit of trig to just figure out the change in velocity, and I plugged it into our trusty impulse equation. Thanks for watching.